Hello and welcome to our STEAM project number 14, featuring the Raspberry Pi Pico and MicroPython. This lesson is part of our Sherpa level series, designed for the somewhat experienced STEAM teacher. Today, we are going to explore how to create datasets over a longer period of time and how to export this data in other programs such as Excel. My name is Peter, I am the founder of Educomondo and a certified STEM instructor and course designer. The goal of today is to learn how to work with files in MicroPython. We will learn how to handle files like create new files, append data to existing files, copy and move files from the Pico. We will exercise the error handling using the try and accept method. We will show you how to import the CSV file in Excel for further analysis. And the most important as always, make sure your class works as a team to find solutions, help each other and present their project in a clear way. For this project we will need a breadboard with the Raspberry Pi Pico, the DHT11 temperature sensor and a bunch of jumper or preformed wires. Building the project is very simple and it shouldn't take your class more than 10 minutes to have it all connected to the PC and have the Thonny development environment up and running. The DHT11 module has 3 pins, a voltage pin, the ground pin and a signal pin. The voltage pin is connected to the volt pin of the Pico and the ground to one of the ground pins. We have chosen pin number 16 to capture the signal from the sensor. You can show your class the fritzing drawing in case they have any doubts. So let's go to our live Thonny environment. Here we are in our Thonny environment, and as you can see I have put here the structure of the program, and I think it's a good idea to do this upfront with your class, is to brainstorm what would be the structure of the program in order to achieve the objective. And the objective is to measure temperature data with our DHT11, capture that data and write it to a file. So the libraries and the hardware setup are things that are quite well known by now, but the main code is something that we need to think about. So what do we want? First of all, we want to get input from the user because we want to ask him whether they want to create a new file or append to an existing file. Those prompts are a source of errors, so we need to make sure that we capture those errors and correct them. So it's the error handling which will be done by a try and accept block. Then we are going to write to file, to a CSV file, the data that is captured by the sensor. And as a control mechanism, we also want to see something on the REPL because we want to show the number of measurements, where we are in the measurements, and what is that measurement, so that we can control the flow and the measurements also to see if those make sense. And then maybe a bit outside of the program, but we also will see how to save the file and how to import it to Excel for further manipulation. As I said, I'm not going to spend too much time on the libraries because we know this also in the hardware setup. We have seen this in a previous lesson. But what is important is this part. As I said, this is the input validation and error handling. And we are going to solve this or approach this through the creation of a function. And we call this function the getValidatedInput. So this will make our program a lot more robust in that respect. So def getValidatedInput, this defines a function called getValidatedInput that will take a prompt, which is the question asked to the user, and a list of valid options. And we will create that valid options later in the program. For this, we are using a while true. This will create an infinite loop until a valid input is received. So as long as the user is giving an input that is outside of those valid options, that loop is going to continue. The if statement here, if the user input is within the valid options, it's going to check whether that input is present in the list of those valid inputs. If not, the return value or the return user input, if that input is valid, the function returns that input and the loop will break. Else, we are going to print an error messages showing the valid options and the loop continues. So this is where we will see those are the valid options. Now we are going to ask the user for some information. And the first thing is here the number of measurements. It's going to ask the user for the number of measurements and converts that into an integer. The time span is another prompt. It is going to ask the user for the time span between the measurements, and it will convert that input to a float, so a number with decimal points, so that in case somebody wants it between, or the time span of 2.5 seconds, it will be possible to do that. The next step is the file mode, and the file mode will use the validation function, so this getValidatedInput, to ask if the user wants to create a new file or an append to an existing file. So if file mode is equal to new, in that case the user chooses new, it's going to ask for a file name, and it's going to use the try and accept block. So this block, the try and accept block, to check if that file already exists. If it does, it will prompt for a new file name. Else if, when it's not a new one but an existing one, it's going to ask again for an input, for a file name, and once again it's going to use this try and accept block to check if the file name already exists. If it doesn't exist, it will print an error message, and it's going to prompt again for a valid file name. Now, as you can see, both here and here, I'm using with open file name read as f. So open is a built-in function that opens the file, pretty straightforward. The file name is our variable that contains the name that we have received from the user. R stands here for read. So it's going to be opened as a read mode, meaning that you intend to read the data from that file. Now, there are others that can be used, so we can also open it as a write, a W. You will also see that we see here it is read. In this little bit below, it is as A, which stands for append. So it's going to open the file and it's going to append data to the end of the file. And then there are some others like X and B that we will, but that you can have a look at on your own to see what these mean. But we are not using those. So append and R, so read and append, are the most common ones that we are using. So with open append as a CSV file, so this is also quite important because we are using it in the append mode, and the with statement that we are using here ensures that the file is properly closed even if an error occurs. And the CSV file is the file object that we will use to write to the file. We are going to use sensor measure, so this is going to start the measurements from the sensor. This is needed to update the sensor's internal values. The temp C is the variable that comes from the sensor values. It's going to read the temperature from the sensor and stores it in the variable temperature C. And once again, we are going to start a for loop. This starts a loop that runs for the specific number of measurements that we have received from the user. And what are we going to do in that for loop? Well, first of all, we are going to create a formatted string. So a data string, a formatted data string that contains the data, the time data that we want to capture along with the measurement. If we are doing this just for fun almost, but if you want to do this for a longer period of time, it's nice to know when exactly the measurement was taken at what time. So this creates a formatted string. So the data string is a formatted string containing the data, and what is that date is the U time. So this is where the library comes in, and the functions here, so 0, 1, 3, 1, 2, 3, and so on, they refer to, or first, the year, the month, and the date. So 0 is year, 1 is the month, then it's the date. On number 3, it's going to be the local time. Number 4, so local time in hour, minutes, and seconds. So hours, minutes, and seconds. And then the temperature. And as you can see here, a little bit later, and so this is the temperature, and then /n, which means that there will be a new line created in the file. So don't forget the new, because that's quite important. So that's the data string that we are going to capture, which will then be shown in the different cells of the Excel sheet. Now we are going to measure or do the measurements according to a certain time interval, which is the time span variable that we have also received from the user. And then we're also going to print something to our REPL. As I said, it's always good to check the progress of these measurements, and this is just a print function with the measurements, measurement +1 of the total, let's say 10. We are going to have the temperature that is going to be captured in centigrades. And then when the loop is finished, we are going to print the data collection is complete, so that you know that it's still going on if that message has not yet appeared in your REPL. So let's see if it works. So we're going to run it, enter the number of measurements. So that's good. So we're going to say 10. I want to have 2 seconds in between. I'm going to write a new, or I'm going to create a new file, but I'm going to type a mistake. So I'm going to type a mistake, and my error handling seems to be working quite well, because it says it's an invalid input. Choose new, and I'm going this time to say new. Okay, what is my new file? Well, I'm going to call it temperature test 1 or _1, temp test _1. And yes, it starts measuring. So measurement 1, measurement 2, measurement 3 and 4, and so on. So that seems to be working quite well. Every 2 seconds. And after the 10th of 10, it says that the data collection is complete. Now I want to do a new one, and I should not forget the temp test one. So I'm going to copy this one. Again, I'm going to do, very careful always that you are here in this part, so that you do not make a mistake somewhere in the code. 2 seconds in between, and this time I'm going to append, but once again I'm going to make a mistake in what I write, and also this error is nicely captured by the program. So I'm going to append. Here I'm going once again make a mistake, so I'm going to call this 0, and it says it does not exist. Enter an existing file name. So I'm going to use the right name, and the program starts to run again. Very nice. At this moment, we know that the program works. We know that the measurements are being taken, but the big question is, of course, have we created a file, and in that file have we captured all of the individual measurements? To find out, we need to open the file structure that is on the Pico. So open. And here you have the option either to open a file from this computer, your local computer, or the Raspberry Pi Pico. We take the Raspberry Pi Pico, and as you can see, we have quite a number of files here. And this is the one that we have created. So I'm opening it up, and you can see that the measurements have been taken, that the date comes first, and then we have the temperature measurement, and that it is also nicely separated by commas. So at this stage, all looks great. Now, of course, we can't do anything with this, so we need to import it into an Excel file. And how to do that? We need to go to File, and we have to save this as another file, this time on your computer, and you can do it in any folder that you want. I prefer, of course, to do this in our folder that we are working, the folder of the project, and it pre-populates the name, but be careful, it thinks that it is a Python file. And that is not the case. So you need to put everything into all files. And I also recommend you to type the extension CSV. This will help the computer to immediately recognize the file as an Excel file. So you will see if I save this now and I go to my file, to my files. Here it is, and you can see the icon is there for an Excel sheet. If I double click on that one, Excel nicely starts, but it shows me exactly the same. So the commas are not really interpreted as separations of the different cells in this spreadsheet, because we need to import a CSV file, not just open a CSV file. So I'm just creating a new worksheet here, and under data you have the option from text /CSV. I click on that, and once again I have to find my file. This is the one, and I'm going to import it. And the first thing that it shows us is an opportunity to double check whether indeed the commas are separating the values and put those values into different cells, but also to change a number of parameters. For instance, if you use a different delimiter, or you want to have another area here, that's all possible. So this part I am loading. I'm going to load it, and you can see that I have a very nice worksheet with all of my measurements. There are 20 measurements. I can change the column names and so on and so forth. So all of this seems to be working and is now ready for you and your classroom to do additional manipulations. For instance, like calculating averages or creating nice looking graphs. So this is how you actually start manipulating and working with files that have been created by capturing data, a lot of data, through your Raspberry Pi Pico. I hope this project works for you too. If not, well, you know, and your students know it. No time to panic, but to conduct some critical review of the code and checking both error messages and the physical project. Combining the standalone weather station project with logging data is a great project where your students will be able to collect data over a longer period of time, for instance 24 hours. Using the DHT11, they can add humidity readings also to the data logging. This project is also a great opportunity to teach about some cool Excel functionalities like making graphs or other visualizations. And that's it for lesson 14. I am confident as always that you and your class found it very useful, and you will start collecting your own data. In our next project, number 15, we will dive a bit deeper in the math of Python and use this to calculate the speed of sound. I look forward to seeing you again. Bye bye for now.